Okay, in this lesson we're going to talk about compound inequalities. A compound inequality is just two inequalities that are connected by the word and or the word or. So the word and or the word or. And on this page I just have a few examples of what compound inequalities look like. The first two, x is greater than 5 or x is less than -3. Number 2, x is less than -8 or x is greater than -1. The last two, examples 3 and 4, are both ones connected by the word and. But one of them is using the word and one is not. You can, in each case, you can write it the other way. So like in number 3 where it says x is greater than 4 and x is less than 9. This one you could also write this way. And that's the same thing where we just kind of pushed them together. And then in this bottom one you could write -2 is less than x and then use the word and x is less than 6. And you could write it that way. Most of the time you probably see them say x is greater than -2 and x is less than 6. Then that would be the same thing written with the word and. So you'll see them both ways. Okay, on this page, it just asks you to graph each compound inequality. So number 1, you have x is less than 3 or x is greater than 8. So what we're going to do is we take our line and we're going to put some numbers on it. Okay, 0, 1, 2, 3, 4, 5, all the way up. And all we're doing now is just what we did in the first lesson where we're going to show solutions on a number line, only now we have a compound inequality. It says that x is less than 3, so we put an open dot on 3, and we would shade that going to the left. Or x is greater than 8, so you have an open dot on 8, and that would be shaded to the right, since those are the numbers that are greater. And oftentimes then the or inequalities will look like this. You'll have shading on either side. It is possible that you have shading just going one way, but most of the time that's what it would look like. On the second one, you have x is greater than or equal to 14 and x is less than 19. So it's the same thing. We need to get some numbers on the line to make it a number line. And then now we just put our dots and our shading the way they would belong. Right? X is greater than or equal to 14. We'd have a closed dot here. And then we're going to shade to the right, but it says and x is less than 19. So you'd have an open dot at 19, and you would only be talking about the numbers that are in between, because it says the word and. It has to be both. It has to be less than 19, and it has to be greater than or equal to 14. So those are only these numbers that are here in the middle. Okay, the next page, right, it asks you to write an inequality that represents the statement and then to graph the inequality. So on the first one, x is less than 12, that's easy, x is less than 12, right? And it also says that x has to be at least 7. At least 7 means greater than or equal to. Okay, and so you could rewrite that with, remember, anytime it's got and, you could rewrite that as one inequality. And so that would be this one. And that has the x is greater than or equal to 7 and also the x is less than 12. And then all you have to do is get your numbers on. And so now it has to be, when you have it written without the word and, you can kind of see what it's going to look like on the number line. If you look at that, you can see the 7 is kind of the beginning part on the left, and then the 12 is the the high number, x is in between those things. So x has got to be greater than or equal to 7. So I'm going to shade to the right of the closed dot. But it has to be less than 12. So I have to shade to the left of that. And that leaves us these numbers that are in between. Okay, number 2, where it says x is greater than -2. So x is greater than -2 and at most. So if x is at most 5, then that means that x is less than or equal to 5. So it's very similar to the one we just did, only it says at most. And this one, when you do it, you're going to get the -2 here, x in the middle. There's the 5, and so you have your beginning points again. And so you have your -2 is a smaller number, 5 is the bigger number. X has to be greater than -2, so it's an open dot. And then x is less than or equal to 5, so since it could be 5, we put a closed dot here. And it has to be to the right of the open dot, because it has to be greater than -2, and to the left of the closed dot, because it has to be less than or equal to 5, which would make these numbers in between, and there would be my graph. On the next page, we start solving our inequalities. And so on this one, just a compound inequality. Got the word or. So all it really means is we have two inequalities to solve. So we'll just do exactly what we would normally do. In this one, we would subtract 6. And if you subtract 6, the left side is going to be 2x. And the right side is going to be 12. And then after you do that, you're going to divide by 2. And since I'm dividing by a positive 2, I would just leave it as less than sign. I don't switch the inequality. On the second one, I need to solve this one by dividing by a -3. And so there, since it's a -3 that I'm dividing by, I would switch from a less than to a greater than sign. And I would get that x is greater than, oops, need to get rid of a negative. X is greater than 9. And I can write my answer. And I need to have two inequalities. X is less than 6, and then I make sure I put the word or x is greater than 9. And then if you needed to show that on a number line, you could do what we just did on the previous page. Okay, next example that I have here. Okay, this is an and. And we have two choices. We can solve it. First, we could solve it as two inequalities. And if you're going to solve it as two inequalities, you want to look at it this way. There's one inequality that you would solve. -5 is less than 2x plus 3. And we have the word and, remember, because the way it's written. Our second inequality is this one. 2x plus 3, same 2x plus 3 that we had in the first inequality, and it's less than 7. And we need to solve that. Now, to solve each inequality here, we're going to subtract 3. And since I'm subtracting, keep my inequality the same. This would be -8, and this would just be 2x. And I'm going to divide by 2. And since I'm dividing by a positive 2, my inequality stays the same. And I get that -4 is less than x, or you can say x is greater than -4. On this one, you subtract 3 from both sides, and you get that 2x is less than 4, and then you divide by 2, and you get that x is less than 2. And then your answer, which you would write with the word and in between, usually you would rewrite it with the x on the left side. X is greater than -4, and x is less than 2. And that would be one way to write it. If you chose to write it without the and, right, where you would put the x in the middle, you would have -4 is less than x, which is the same thing as x is greater than negative 4, and then you would put the less than 2 here, and that would be the same answer. So that's how you solve it, where you separate the inequalities. You kind of take this and break it into two separate inequalities and solve each one separately and then put them together with the and. The other option is to solve as one big inequality. And if you solve it as one big inequality, here we would, rather than have to do things twice, since I both times had to subtract 3, I could just subtract 3 from all 3 pieces. So I would take 3 from negative 5, and that would be negative 8. Since I'm subtracting, my inequality stays the same. From 2x plus 3, it would become 2x. And when you take 3 from 7, you get 4. So there's 3 areas that you have to remember to do your arithmetic on. And then the second part is going to be the same that we did before. We divide by 2. And since I'm dividing by a positive number, when you get negative 4, the inequality would stay the same, and there would be my 2. That's, of course, the same answer we had on the previous page. You could break it apart, and you could say that x is negative 4 and use the word and. X is less than 2, and that would be the same thing. Now, the last example that I have is x equals 4 a solution to the compound inequality? X plus 3 is less than 5, or 2x is greater than 12. Okay, well, on this one, you have a given x value. Okay, this is the given x value. And in your homework, they give you a question or two like this. All you have to do is solve the inequality. So if I would first solve the first half of it, x is going to be less than 2. Right? Or when you divide by 2, you get that x is greater than 6. So there's my solution. And if I just do a quick graph, number line, right? X is less than 2 would be an open dot here, and you'd be shaded this direction. X is greater than 6 is an open dot there, and you'd be shaded that direction. Right? X equals 4, remember, was my given value. Graphing x equals 4 is a dot there. And so you would say x equals 4 is not a solution because it's not in any of the shaded in area in my graph. Right? There's x equals 4. Right? And this piece right here was the x is less than 2, and that piece right there was the x is greater than 6. Right? X equals 4 is not a part of either one of those shaded in areas.